to day 3 of the webinar series on reducing roadway departure crashes. Looking at the handout section of the GoToWebinar panel, please note that a copy of today's presentation is available for reference. Also, please feel free to use the questions box during today's session to submit any questions you might have. And with that, we will proceed with day 3. Good morning, Ron.
Good morning, Mike. Thank you. Welcome, everyone. Welcome back to our third and final day, talking about roadway departures. We've talked about on day 1 some implementation strategies and some methods to keep drivers on the roadway using pavement marking and signing. Yesterday we looked at that, but we also looked at methods to keep vehicles on the roadway using geometric and pavement related techniques. So today we're going to move on to part 5, which is improving the recovery area, meaning once vehicles leave the roadway, how can we reduce the likelihood that they'll overturn or strike a fixed object. And we'll also get into part 6, which relates to reducing the severity of the crash that does occur. Our learning outcome for part 5 is to describe some countermeasures to reduce potential for vehicles to crash if they leave the roadway. And we'll start with the shoulder. The shoulder, of course, is next to the traveled way. As the slide says, it's where recovery begins. And it could be argued shoulders are most critical on horizontal curves. We've talked about how vehicles are more likely to leave the roadway in a curve. And here we see an example. We don't see much of the shoulder on the straight or tangent sections of roadway, a little bit in the foreground there, but it looks like maybe an 18-inch or 2-foot paved shoulder and then a wider, maybe 4 or 5 foot stone shoulder. But notice this particular agency in the curve itself has put in, what's that, maybe a 6 or 7 or 8 foot paved shoulder around the curve, recognizing that vehicles are more likely to leave the roadway in the curve. And so by having a paved shoulder provides recovery opportunity for the motorist. There are some CMFs for shoulder width. This has been studied to a pretty good extent. Notice here we're showing the CMFs in graphic form rather than in table form. So let me kind of set the stage here. The horizontal axis down here is, this is average daily traffic volume on the roadway from 0 to 2,500 and greater as we move to the right. And then the vertical scale is the accident or crash modification factor from 0.8 to 1. Remember, 1 would mean the improvement had no effect on crash experience, and then up to 1.6 in this case. And the base condition for 1 is a 6-foot shoulder. And then notice down here we see an 8-foot shoulder, which of course is wider than 6 feet. So we would expect an 8-foot shoulder to be safer than a 6-foot shoulder. And this quantifies that. Notice at about 2,000 vehicles per day, the CMF is 0.87 or a 13% crash reduction factor. And we can see it from maybe 0 vehicles to what's that, maybe 300 or 400 vehicles per day. It's 0.98, the CMF of 0.98, and then it varies linearly to a 0.87. If we had a narrower shoulder, we'd expect a higher crash rate. So for example, if we look at a 2-foot shoulder here, you can see at very low traffic volumes, the CMF is 1.07, so a slight increase in crashes. But then notice as volume increases, notice that goes up to 1.3, or that means 30% increase in crashes if we have a 2-foot shoulder compared to a 6-foot shoulder. So this allows us to to look at the effect, the safety effect of different shoulder widths. And there are numerous examples of studies like this or related to this around the country. Here's an example from the Alabama DOT a few years ago, implemented a shoulder widening project or program. You can see they looked at nearly 700 miles of basically 2-lane roadways where shoulders were added. You can see the original condition on the left side there, just a stone or grass shoulder, but then they put in paved shoulders and in some cases rumble strips, not in every case. And they found overall for the whole program a crash reduction of 28% just by adding a paved shoulder. So as I've talked about, shoulders, adding shoulders, paved shoulders do have or can have a significant safety benefit. Another issue, I think we've mentioned it a few times over the last couple of days, but a significant safety issue, especially on 2-lane roadways, is the edge of pavement drop-off. As you see here, actually, I guess it would be fair to call this an edge of shoulder drop-off because this looks like the traveled way here, and then we have a paved shoulder, and notice we can see a vertical drop off. In fact, if you look closely, it appears that there is some tire rubber there indicating that vehicles have scraped up against that edge of pavement drop off. And these happen for a variety of different reasons. The area here, we can't see it, but I've been told this is out of the picture here, is one of these multiple rural mailbox setups. So drivers are pulling off the roadway here to check their mail, and you can see it's damaging the kind of the unsurfaced area, and such that the shoulder is now, the unpaved shoulder is lower than the paved shoulder, creating the drop off.
Hey, Ron.
Yes.
Hi, just a quick question. I think 2 slides back, the graph, maybe one more slide back. There we go. Question from James. Is there a specific study that the graph for CMFs versus shoulder width was pulled from?
I think there is, or it may be at multiple studies, but I think there is, and that I would refer you to the Highway Safety Manual. Off the top of my head, I can't remember the specific study or studies, but it would be documented there, or go to the CMF clearinghouse. That would also be a good source of finding out additional background information about the underlying research.
Thanks, Ron.
I would recommend contacting the CMF clearinghouse or checking that out.
Thank you.
My computer is hanging up today for some reason, sorry. This shows the classic edge of pavement drop off, and you see a drop off there. The vertical drop off would be the most serious condition. And we've all probably seen this, or maybe we've even, as drivers, we've been here ourselves, but notice as the vehicle's driving, in this case around a curve, the 2 right tires drop off the traveled way or off the pavement onto a lower shoulder. And typically what happens, even though most state driver licensing manuals that I'm familiar with, they talk about this situation and they advise drivers, if you're ever in this situation, what you should do is slow down gradually, and then where the drop off is minimal, gently steer back onto the pavement. But it seems like when this happens, if you've ever been behind someone in this situation, it seems the human instinct is to yank the wheel to the left to try to get back on the pavement. But because of the drop off here, the tire doesn't immediately regain the pavement, especially if you have a significant drop off height like this. So it scrubs, would be the accident reconstruction term, scrubs against this edge. That's why often we'll leave tire rubber on this edge. But then what the driver does, since the vehicle's not responding, the driver steers harder to the left, and eventually the steering angle is such that the tire or the vehicle does regain the pavement, but usually the vehicle is in an out of control yaw, Y-A-W. I think we talked about yaw marks on day one. And so the vehicle's out of control, and then either they might be struck by an oncoming vehicle, as you see here. Notice this is a head-on or T-bone type of crash, or if there's no impact with another vehicle, either same direction or opposite direction, the vehicle may often overturn on the roadside here, or they may strike a tree or other fixed object on the roadside. So that these edge of pavement drop-off crashes are among the more serious crashes, serious roadway departure crashes that we have. And that's why there's been a lot of interest in how do we reduce edge of pavement drop-off crashes. Actually, this is from Pennsylvania, but this is kind of the classic edge of pavement drop-off crash, although this involves a truck. You can see here, this is a 11-inch, almost vertical edge of pavement drop-off. A empty coal truck was coming from the top of the photo. They're coming toward us, so it would have been a left-hand curve for the truck driver. And for some reason, somewhere up in this area in the curve, the right side tires went off the road onto this shoulder, which of course is significantly lower than the pavement elevation. The same thing happened with this truck as I just described. The truck finally regained the pavement, but you can see here, notice these curve marks. These are yaw marks that I talked about earlier, kind of oversteering or overcorrection marks. And sadly, what happened here is this is what's left of it was a Chevrolet SUV that was obviously at the wrong place at the wrong time. A mom taking her 8-year-old son to school was struck by the truck. The driver was killed. The child survived, but obviously traumatized. But that's a kind of a classic edge of pavement drop-off crash example of what happens. There are a number of risk factors associated with pavement edge drop-off crashes. Certainly speed is a factor. Driver experience is another big factor. The vehicle and the tires, the drop-off height, and a key factor, as I've highlighted here, is the shape of the pavement edge. This chart is based on some research done at the Texas Transportation Institute, TTI, at Texas A&M University. Notice on the horizontal scale, they have the longitudinal edge elevation change in inches from 0 up to 7 inches. And on the vertical scale there's numbers here, but it's more of, I often look at the description since it's more qualitative maybe than quantitative, but they call this the relative degree of safety. So down here in this category, they call this safe, meaning a driver, even an inexperienced driver, should be able to get their vehicle back onto the road safely. Then in this area, we're talking about reasonably safe, above that, marginally safe, questionably safe, and then unsafe up here at the top. And the curves that you see are for different edge shapes. So notice shape A here is the vertical edge. Shape B is this sort of edge that you see here. Shape C is kind of this wedge-shaped at 45-degree angle. Shape D is the wedge shape at 30-degree angle. And oftentimes in or many states or agencies, excuse me, may have or do have a 3-inch maximum edge elevation at shoulder drop-offs, meaning when that elevation difference exceeds 3 inches, it's time to do maintenance to bring the shoulder back up. And I think you can see here, notice for shape A here, shape A, the vertical edge, we follow that curve. Notice when that gets to about 3 inches here, that's when we go from reasonably safe to marginally safe. So that's that's sort of the reasoning or rationale why some agencies use that 3-inch height. Other agencies may use a 2-inch height, which is roughly where it goes from safe to reasonably safe. But notice with this shape D, the 30-degree wedge, or as it's called, the safety edge, notice that even at 6 inches or close to 6 inches, that is still in the safe, or just moving from safe to reasonably safe condition. So this was sort of the genesis or the background for the safety edge concept, which has been promoted by Federal Highway Administration for many years, that if we can put this sort of a shape on our edge, the conditions will be much safer for motorists. And so the safety edge is discussed in a number of different documents. It's also mentioned in the AASHTO Roadside Design Guide. I would call it a proven safety countermeasure. Here is a video of a vehicle experiencing the return to the roadway from an edge of pavement drop off. There is some audio. It's not really important to viewing this. It's the communication between the driver and the, I guess, the field staff, if you will. But this is a professional driver, a stunt driver, so someone who has experience in these conditions. It's not kind of a new or inexperienced driver, but it's an experienced driver, and you'll see him or her negotiating this edge of pavement drop off. And one thing you can see here is notice this single line of cones here. This test was done at an airport runway, so it's not a roadway. But what they're trying to show with these sets of cones here is to define this lane of travel. So this would be the one lane on a two-way roadway. And then once the video starts, you'll see some doubled up cones just outside the frame here. That would represent the other lane of travel. So once the vehicle would pass those doubled up cones, they'd essentially be off the other side of the roadway. So I'll be quiet now and show the video. I think you can see even an experienced, professional type driver was not able to keep the vehicle on the road. It would have gone across the road onto the roadside, which obviously generally would not be a nice, smooth, level, concrete surface like we have on this airport runway. So this would have been a very serious crash, probably an overturn or hit a fixed object or something like that. So now Mike has a question for you regarding the audio on the video. Mike?
Yeah, thanks, Ron. So question for our audience, we're just trying to verify, were you able to hear any audio during that video clip, or was there no audio coming through to the audience for the video? If you could just type a reply. Okay, no audio. Oh, somebody said yes, audio. But most are saying no. Okay, so it made a little static sound at the beginning, then no audio. Got it. All right, so it sounds like for most of our audience, it sounds like through this webinar platform, we're probably not getting audio out. So that does help us, Ron, that for the upcoming videos, feel free to narrate the upcoming videos as needed. Okay. And Ron, there was one quick question. We were looking at the chart with the edge shapes. Question from John. He says, how does speed factor into the edge shape and relative risk?
That's a good question. It does certainly factor in. I'm not sure how they factored that in this research, to be candid with you. I'd have to go back and look at it. But I believe these were all done or the research was done at kind of highway speed. I'm not sure if it was actual, there was some field testing, but there was, I think, also some simulation done as well. But as I recall it, I'll say highway speed, maybe 45, 55 miles per hour, kind of 2-lane roadway speed, not interstate highway speed, but also not kind of urban street speed at 25 miles per hour either. I'd call it 2-lane roadway speed, probably 45 to 55 miles per hour.
Thanks, Ron.
So this is the safety edge, as it's called. Notice the edge of the newly laid down pavement does not have a vertical edge. It has this 30 to 35 degree wedge, which Federal Highway Administration has termed the safety edge. And how that is constructed is by installing a shoe on the screed of the paver, and that creates the safety edge. I believe the price may have gone up recently, but I believe this, a few years ago, this shoe cost about $1,500 to $2,000. And of course, once it's installed on the paver, you can do multiple paving jobs with it. In fact, very early on, maybe I'm thinking maybe 20 years ago when the shoe first came out, actually several LTAPs around the country. Mike, I don't know if Ohio LTAP had one. We did not, but several LTAPs around the country actually had the shoe and would loan it to agencies within their particular state. So you can see again, notice the safety edge creates this wedge-shaped surface compared to the edge that you'd see without the safety edge. And actually, so not only was there the safety benefit, but kind of an unintended consequence that they found was that the safety edge provides better edge performance, because notice the edge cracking here without that safety edge. So that was something that maybe was not anticipated, but that's another additional benefit associated with the safety edge. Well, obviously, there's kind of an immediate benefit, as soon as the paving is done and the road's open to traffic, even before maybe the contractor or the road agency has brought the shoulder back up flush with the roadway. If people leave the road, they have the benefit of that safety edge. And of course, over time, as the shoulder may erode or deteriorate or whatever, what you're left with is that safety edge surface, not the vertical edge surface. One of the big benefits is reduction in tort liability claims because fewer crashes. It's estimated that the cost is less than 3% of the material cost. Obviously, as you can see, there's little additional material needed because of that edge or that wedge shape, but that is not really significant. And as I just mentioned, there's increased pavement edge durability. Now, one concern folks had, including me, was this is not really compacted, that edge, to the same degree the pavement would be. So what happens if a vehicle does go off the road? And you can see here what this photo is trying to show, that even after the passage of this large rig, that edge is still in pretty good shape. But of course, the intent is not to leave it permanently in that state. The intent is after, the paving is done, but before the project is complete, is to bring that shoulder back up flush with the pavement surface elevation. But as I mentioned, then over time, you still have the benefit if the shoulder does erode or deteriorate. And here's an example. I think this is from Alabama. The project was constructed in July of '03. You can see that it was a test project. One part of the project used the safety edge, the other did not. And these photos were taken about 8 years later. You can see the shoulder has eroded or deteriorated, but notice with the safety edge, you're still left with that wedge shape, which should make it such that drivers can get back on the road without serious issues. Whereas this portion of the roadway, you're left with, or drivers face that vertical edge, which creates the safety concerns that I talked about. In terms of CMFs, the CMF value for total crashes for the safety edge is 0.94, which would be a 6% crash reduction. Research also shows a benefit cost range of 4 to 63, which is pretty significant, of course. So that would be for every dollar invested, you get a benefit of up to $63 in terms of crashes reduced, injuries reduced, and so forth. So that was the safety edge. Another area of concern on the roadside is the slopes and ditches. We want to prevent rollovers on those slopes or ditches. And maybe we should mention the steepness categories of slopes. AASHTO talks about 3 different categories of slopes, what they call the recoverable slopes, which is 4 to 1 or flatter, and that means 4 horizontal to 1 vertical. And notice this category, the recoverable, has 2 asterisks associated with it. The asterisks means that that slope is traversable. Traversable means the vehicle will remain upright and not be unstable or not overturn. So recoverable means the driver could brake the vehicle to a stop if the driver is conscious and alert and so forth. Or again, if the driver is conscious and alert, could steer the vehicle back onto the roadway. So that's what's meant by recoverable. Now, the non-recoverable, you can see, is a steeper slope. And basically what this means is that even if the driver braked or steered, they could not get back on the roadway or they could not stop the vehicle. The vehicle would roll to the bottom of the slope. But it is traversable, meaning the vehicle would remain upright and would not overturn. And then the critical slopes are those steeper than 3 to 1, where the vehicle would overturn on that slope. And typically these slopes would probably, depending on the height and so forth, would probably have guardrail at the top of the slope because they are critical slopes. So here you see an example of the recoverable slope. Non-recoverable, a little bit steeper than, of course, the recoverable or the 4 to 1, but both of these are traversable. The vehicle would remain upright. But then the critical slope, 3 to 1 are steeper, not traversable. The vehicle would roll over. And of course, this does not appear to be a recoverable slope. I'm not sure exactly what happened here, but to me, not a good situation from a safety standpoint. There are CMF values for different slope conditions. Of course, flattening slopes like this is not in my opinion, not a low-cost countermeasure. Probably doing oftentimes significant earthwork, earth moving, and so this is not a low-cost countermeasure, but certainly it has and can have a positive effect on safety. So notice this particular table from the Highway Safety Manual. The treatment is flattening side slopes on rural 2-lane roads for all types of crashes. And you can see here the side slope before and then the side slope after. And of course, we're making the slopes flatter, and you can see a considerable difference here in the crash modification factors. Another way to address reduce the likelihood that a vehicle will crash when it leaves the roadway is to remove or relocate objects in hazardous locations. And that brings into play the term clear zone, which the AASHTO Roadside Design Guide defines as the unobstructed, traversable area provided beyond the edge of the through traveled way for the recovery of errant vehicles. So in this image here, this particular roadway, the clear zone would start at the edge of the traveled way here. So this paved shoulder would be part of the clear zone, but then also the area beyond that paved shoulder. Notice, at least in the foreground here, it's free of fixed objects. It also looks like it's a relatively gentle slope that would be a traversable slope. So that would be an example of applying the clear zone concept along, in this case, it looks like a limited access roadway. The clear zone has been of interest for a number of decades. Interestingly, the first research in this area was not really done by road agencies. It was done by the automakers, interestingly enough. And this is just some data from General Motors proving ground crashes. If you think about it, of course, the automakers have test tracks or proving grounds, or I guess they go by various names, where they test their vehicles in a variety of different manners. But one of those is probably a test track where the vehicle is driven around maybe an oval shaped track to test the vehicle for various sorts of things. And as you might suspect, in a closed track like that, if a driver's doing that all day, there's issues just like on a public roadway, issues with drowsiness, drivers fall asleep, or there's equipment failures, so drivers leave the roadway. And so, as I said, some of the earliest data on roadway departures comes from the automakers themselves. And this is some GM data. Down here on the horizontal scale is distance from the edge of the pavement that the vehicle traveled when it went off the road. And this is the percentage here. And notice about 40% of the vehicles stopped within 10 feet after leaving the roadway. 80% traveled no more than 30 feet, and 90% stopped within 50 feet. But some vehicles went as far as 100 feet, or probably more, off the roadway. And maybe because traffic engineers kind of oftentimes used to look at the 85th percentile speed, and roadway engineers looked at this and said, well, 80% travel no farther than 30 feet. Let's make the clear zone 30 feet. And interestingly, there was also some data done by collected by the Illinois DOT, where medians on limited access highways in Illinois, and they found that similarly, 80% of the vehicles went no farther than 30 feet. And so back, I think it was in the late 70s, AASHTO adopted a 30-foot clear zone. But if you think about it, having a 30-foot clear zone on every roadway is not necessarily a good thing, especially on, for example, urban streets. A 30-foot clear zone may mean we need to remove structures from close to the roadway. So over time, that 30 feet has been adjusted to reflect speeds and side slopes and average daily traffic volumes. And now if you look at the AASHTO Roadside Design Guide, this is the current AASHTO Clear Zone guidance. And a lot of information here, we're not going to really look at it other than to note that, notice the clear zone is a function of speed of the roadway. There's several different categories. The design average daily traffic volume, again, several different categories from lower volumes to higher volumes. And then the foreslope and back slope of the roadway. And you can notice for lower speed, lower volume roads, you're talking about a clear zone of 7 to 10 feet. For higher speed, higher volume roads, the clear zone you can see, in this case, even goes up to 42 feet or more. So the clear zone depends on these factors that I've just mentioned. But again, remember, this is based on the assumption that 20% of the vehicles will exceed the clear zone, and that does happen, of course. as you see here. And then they provide a clear zone adjustment for curves, recognizing that motorists in curves often go farther off the road than they do on a tangent or straight section because of the curvature. So they developed multiplicative factors, you probably call them, depending on the radius of the curve and the speed of the roadway. Here we see the percent distribution of fixed object crash deaths. So these are fatalities by object struck. And the first day someone asked a question I thought may be related to this. If this doesn't answer the question you raised on the first day, let me know. But this is a more detailed breakdown of the various fixed objects that motorists strike along the roadway. We talked about how trees are the most frequently struck fixed object, almost half of the fatalities. The second most frequently struck fixed object, and again, this is nationally, is utility poles at about 12%. But notice the third most frequently struck fixed object along roadways is the traffic barriers, the guardrails and other barriers that we install to shield hazards. So the point is these barriers themselves can be and are regularly struck by motor vehicles and cause death and injury. And then you see the more detailed breakdown here. Notice embankments, ditches, sign supports, culverts, fences, bridge piers, walls, buildings, light supports. Many of these things, of course, are items that or features that we in the public works field install along roadways as part of road construction or even to enhance safety. And the point is that they can represent fixed object issues for motorists who leave the roadway. But probably the big two in the United States generally are trees and utility poles. Although again, it depends. Last week I taught a class for Nevada LTAP, and we were talking about roadside safety in that. And there in that, it was many of the participants were from the high desert of eastern Nevada, where they don't have many trees. So trees were not a big roadside safety issue there. Their main concerns were highway sign supports and culvert headwall related types of features. So the numbers you see here are nationally, but specific locations, specific states, specific areas may have slightly different results just because of the nature of the area. So we're going to focus on trees and utility poles. And in fact, the NCHRP Report 500 series, you can see has a whole volume dedicated to a guide for addressing collisions with trees in hazardous locations. And they talk about one strategy is to prevent trees from growing in hazardous locations, which would probably be the best solution. But once a tree is grown, of course, it may be difficult to remove that tree. But if we can prevent them from growing in the first place in hazardous locations, that is often the best approach. Another strategy is to eliminate the hazardous condition if we can do that, and or reduce the severity of the crash. So prevent trees from growing in hazardous locations, maybe develop, revise, and implement planting guidelines to prevent placing trees in hazardous locations, and having mowing and vegetation guidelines to address these things. To eliminate the hazardous condition or reduce the severity of the crash, if we can do it, remove trees from hazardous locations. I'm speaking of trees, for example, very close to the road, or trees on the outside of a sharp curve. Another strategy would be to shield motorists from striking trees using barriers or other devices. Maybe modify the clear zone in the vicinity of trees. Or if we can't do anything else, maybe one thing we can do is to delineate trees in hazardous locations. So at least drivers can see the trees, and if they're conscious and if they're in control of their vehicle, hopefully they could avoid striking the trees. Wanted to mention avoid placing trees in hazardous locations. Notice here we do have an urban situation. We have a tree lawn or furniture zone or buffer strip between the sidewalk and the street, which is a good thing. And notice there are a number of street trees, we'll call them, that have been planted in this buffer strip. I think the things that concern me are, number one, if these are all the same species of trees. This one and maybe a couple more in the background here seem to have grown to a pretty large size, such that these do represent fixed obstacles that could cause harm to motorists that leave the roadway. So think about maybe the species of tree in terms of what their maximum size might be and the spacing of the trees and that sort of thing. Because these are maybe like 18 inches behind the curb or so, so they're very close to the roadway. And of course, one other thing that these trees, another issue they present is not related to roadway departures, but as many of you know, these trees, depending on the root system, the tree roots can heave up the sidewalk slabs and create ADA accessibility issues, or can create trip and fall hazards for pedestrians. So that's another concern related to trees close to the roadway where you have sidewalks. If you can do it, remove trees in hazardous locations. I think I showed this image earlier in the class, first or second day. Tree that literally looks like it's growing out of the edge of the pavement, has been struck at least 2 times now. This to me would be a good candidate for removal, although that may not be possible. This is a historic area, so this tree may have some historic significance, but to me, if we could remove that tree would be a good candidate for removal. Or because it's close to the road. Or for example, here it looks like we have a tree, you can see a curve here, kind of on the outside of the curve, is closer to the road maybe than other roadside features. So to me, that would be a good candidate for removal if we can do that. And don't forget the stumps. I commend this agency for removing some trees, but the general rule of thumb is the stump or bases like this should be no more than 4 inches high, and these look like they're more than 4 inches high. So what could happen is the vehicle runs off the road, the undercarriage could snag on those stumps, the vehicle could flip, it could vault, could rotate, could stop suddenly. And so when we're cutting tree stumps like this, the magic number, if you will, would be 4 inches. The stumps should be cut so there's no more than 4 inches projecting above the ground. And this is more of a rhetorical question than one that has a specific answer, and this is some of the challenges we face in roadway departure safety, is how do we address corridors with dense trees that are close to the traveled way? And like I say, it's a challenge, and the answer is probably going to depend on the specific context or situation. National Cooperative Highway Research Program Report 440, which is the accident mitigation guide for congested rural 2-lane highways, presents this table showing the % reduction for relocation of roadside hazards. And you can see there's fences and guide rail and mailboxes and trees here. And obviously we're not going to relocate trees probably along the road, but it shows the % reduction in crashes depending on how far a tree is from the edge of the roadway. And you can see, of course, as the distance increases, the crash reduction increases. But at least this quantifies that. I think this is in California, but this is an interesting technique of shielding the motorist from striking the trees. And I'm not sure if this tree is historic or if it's kind of an endangered species of tree or what, but notice they kept the tree there relatively close to the roadway, but they have kind of shielded it or attempted to shield motorists from that tree. So you notice there's a concrete traffic barrier here with earth mounds on either end to avoid striking the blunt end of those barriers. And there's also the object markers to identify the fixed object along the roadway. So I thought this was kind of an interesting approach. Here's another one. I think this is also California. Don't see this often, but I thought this was an interesting approach. Again, a tree, a fairly large tree or grouping of trees close to the road, but notice they're using the sand-filled barrels or impact attenuators in front of the tree. So at least if a motorist runs off the road and heads toward those trees, it should be a survivable crash because of the impact attenuators that are present. And here's another one. I think this is also California, the Pacific Coast somewhere. Notice these trees relatively close to the roadway, relatively large, but because of the setting in this coastal area, I would say these trees are probably untouchable. They're probably important to convention and visitors bureaus in terms of attracting people to this part of the state. So they want to retain the trees, but also provide roadside safety. And you can see what they've done here. Notice they have a paved shoulder. What's that? Maybe 4 feet or so roughly. And then they use these ceramic buttons or dots. They're kind of domes, if you will, dome shape, as sort of a rumble strip, I guess. It has a rumble strip effect. I don't think we could use these in much of the area that we have folks attending today from Ohio, West Virginia, upper Midwest. These are not certainly snow plowable. In our case, we probably want to use a rumble strip, but in this part of California, they don't have to worry about plowing snow, so they use these ceramic domes, if you will. The other thing I would note is these are not very bicycle friendly. These can cause serious problems for bicycles. But then also notice the other thing they've done is it looks like they've put reflective yellow tape on most, if not all, of the trees. So they've done several of the things we've talked about. They've separated with the paved shoulder. They've provided some warning for motorists with these buttons or dots, but they've also delineated the trees. Here is another video. I'll show several videos today, but really this is the only one that's narrated. The other ones are silent videos. So you won't hear the narration apparently based on the survey that Mike did, but I will try to narrate as we go through here. The only thing that you'll miss is the narrator's pleasant Australian accent. But this video shows I guess I'd call it probably a smaller size passenger vehicle that runs into a large tree. And this is part of a test setup. But I'll narrate sort of some of the things that the commentator notes as we go through here.
There it goes, there it goes.
So the vehicle's at 55 miles per hour.
That'll give you a headache. Come on.
And if you read the lips, he says that would give you a headache.
What makes this devastation particularly sobering is that on a quiet country road, the accident might not be discovered for quite some time.
And he talks about how the crash might not be discovered or responded to for some period of time if it happened on a rural
Well, the
road.
door still opens.
He's
That's the
remarking
base,
how
that's
he's
expected.
surprised the door
The
even
pedals have
opens,
moved.
given the
It looks
severity
like
of the
his
crash.
left leg will be fairly badly damaged.
But he
because there's
notes the
a knockback
pedals
to
have
the
been
pedals,
pushed
and
back,
there's some intrusion again in the footwell.
and he believes the
Although the interior doesn't
driver's
look too
left
bad, this
leg
car has decelerated
would have been
55 miles
broken.
an hour to zero in just over a
But
meter.
because the
It doesn't
vehicle
cause
went
massive
from
trauma to your
55
internal organs.
to 0
To really get a sense of the
in
engine's
about
fault,
4
you have to
feet,
look at the front of the car.
he
Look,
believes
that's
the
one
most
corner
serious
of the bumper.
impact would be the
That's
trauma
just
to
the corner.
internal organs
They've
because
almost
of that
met.
rapid
You can touch them
deceleration.
together. The car's wrapped round the tree.
And now he's talking about how the
Indeed,
vehicle
aerial
is actually wrapped around the tree.
rippling the solid metal bodywork as it goes. Given the vast majority of cars on our roads don't have a 5-star safety rating, the results of similar crashes are often even more horrific.
So clearly that would have been a fatal crash, at least to the front seat occupants, just because, as I said, of the trauma to the internal organs. But that shows you what can and does happen when vehicles that depart the road strike certain fixed objects, in this case, a large tree. Remember, trees are the most frequently struck fixed object in the United States. The second most frequently struck fixed object are utility poles. And these are a challenge as well. They're often regularly spaced along the roadway. They're often relatively close to the edge of the roadway. So how can we address collisions involving utility poles? Here are some alternative safety treatments for utility poles. We can place utility lines underground, and I'm aware a number of new developments around the country. This is in fact what they do, putting the lines underground. To do that, I think for existing situations, of course, becomes very expensive, so cost is an issue. But that's one way to get rid of the utility poles along the road, is place the utility lines underground. If possible, maybe increase the lateral offset, especially say in a curve, which relates to the third one there, relocate to less vulnerable locations. So maybe in a curve, if you can do it, maybe move the pole to the inside of the curve rather than on the outside of the curve, which is a more vulnerable location. And of course, many of these, or all of these, obviously need to have the cooperation of and coordination with the utilities as well. But maybe increase the pole spacing, multiple pole use, meaning multiple utilities using the same poles, which I think that has been done for a number of years. And then actually, I don't know if anyone's seen it, there actually is a breakaway design that I believe has been approved by Federal Highway Administration for use for utility poles. And here is what that looks like. You can see it's kind of a conventional utility pole. It has this slip base here. You can sort of see it maybe. This is designed when the bumper of the vehicle strikes this. These bolts, I guess, are designed to shear off, and then this will sort of flip up forward out of the way. But of course, unlike a sign, say, along a highway, where the sign can just sort of fall to the ground, with the utility poles, of course, we may have some active utility lines, power or other lines up here. And so you can sort of see, here's the base. This was the original base. The vehicle left the road, struck that base, it sheared off, and then notice the pole has come down. But of course, you have this hinge here to support the utility lines themselves. But as I understand it, this is an approved design. I've not seen it used very much, maybe because of cost issues, but I don't know if anybody in the audience has used this or has any experience with this, but this is one way to address the utility pole issue in certain vulnerable locations, would be to use a breakaway pole. And as I understand it, you see the site here, as I understand it, this is the vehicle that struck that pole. Obviously, it's badly damaged, looks like it's totaled, but as I've been told that the driver walked away from this, some bruises and cuts and scratches, but the driver was not seriously injured in this crash. So without the breakaway concept there, the vehicle hitting that pole more than likely would have been a fatal crash. Another countermeasure for utility poles is location. And certainly they should be outside the traveled way. But as I go around the country, not unusual in municipalities, I see this. In fact, I think we have a couple here in Morgantown where I live, where the pole is actually in the street, in the traveled way, in front of the curb. In fact, notice in this location, which I'm not sure where it is, notice they even used the utility pole as the support for the stop sign. Not a crash-worthy support. Remember, we talked yesterday about signs need to have crash-worthy supports. The utility pole is definitely not a crash-worthy support. And then here's a rural example. I'm not sure what happened here, but this just seems to defy common sense from my perspective. If a vehicle hit that pole and the occupants were seriously injured or killed, and there was a lawsuit against the road agency, I'm not sure how you would explain that to a jury, that the pole was in front of the guardrail. If nothing else, delineate the roadside obstacles. Notice this roadway here. I may have showed one similar to this earlier in the week, but notice there's really no defined like edge line or other visual cue between the shoulder of the road and the traveled way. But at least here, they do have nice large object markers, looks like at each pole, to at least delineate the pole for the motorists. A little bit of a review here. Which of these are true regarding the clear zone? And you can type your response in the chat, and Mike will share some of the results as they come in. So which of these are true regarding the clear zone? A, it is an acne medicine. B, it's the farthest distance a vehicle will go when it runs off the road. C, it's the unobstructed traversable area provided beyond the edge of the through traveled way for the recovery of errant vehicles. Or D, the clear zone does not extend outside of the right of way. So what are your thoughts on that? Which of these are true regarding the clear zone? Mike?
Thanks, Ron. Yes, and the responses are arriving very fast, and probably the most frequent response is for C.
Yes, that's kind of the textbook definition of the clear zone. So I agree with that. And I don't know if anybody's Googled it. The first time I saw this little quiz, I wasn't sure either. I responded C, but I did, it's been a while, but I have Googled clear zone, and one of the items that comes up is that it is an acne medicine. So I had a little trick question here. So actually it's A and C, but of course the response that we're interested in is the roadway engineering definition of clear zone. But apparently it is also the name of an acne medicine. Here's a little exercise. Again, you can type your comments in the chat. Identify some countermeasures. I ask what countermeasures that we've talked about today or in the previous 2 days might apply to this location, and what crash reduction might we expect from each. But an important note, the area on the right, meaning off the shoulder here on the right, this is part of the Franklin D. Roosevelt Home/Presidential Library in Hyde Park, New York, operated by the National Park Service. So this is not your average roadside here. This is part of a the Roosevelt Presidential Library. So that may affect your selection in terms of what countermeasures you think could be applied here. So I'd welcome thoughts on what might be done there. Give you a few minutes to think about that.
All right, thanks, Ron. Already, people are typing things such as shielding, cushioning, delineation, rumble stripes delineators, guide rail and delineators, rumble stripe, delineate the tree or remove it, concrete barrier with guardrail ahead of it, rumble strips, removal of tree, rumble strips and delineation, chainsaw, removing the tree, delineate tree, impact attenuators, guardrail, remove tree, etc.
Okay, good responses, good responses. Let's talk about some of those. Certainly, I think people mentioned edgeline rumble strips. I think that would be a good one. Maybe a wide edge line. I don't know if maybe somebody mentioned that. We talked about that the other day. Some mentioned guide rail or guardrail or impact attenuators. I would agree with that. I'll say generally, my only hesitation is, and maybe somebody in the class with us has some firsthand experience from a local project, but I don't know how the Park Service would react to that. I think from a safety standpoint, guardrail here or impact attenuators to me makes sense. I don't know whether those would be acceptable, in this type of environment. That's my only sort of question there. So I think those are certainly good things to look at. Delineating the tree, again, I think that would be good if that would be allowed. My only concern about the chainsaw and cutting the tree, which personally I think that would certainly eliminate the hazard, which we've talked about, that should be the top priority. But I'm not sure that given that this is a historic site, I'm not sure we'd be allowed to touch that tree. But if that could be done, that probably would be maybe the first thing we should look at doing, would be to remove the tree if that would be allowed. But I suspect maybe young Franklin Roosevelt maybe played under that tree as a child or something, and so it may have some historic significance. But good responses there. So that concludes part 5. We talked about countermeasures to reduce the potential for vehicles to crash if they leave the roadway. Any questions, concerns on that material?
All right, thanks, Ron. And I think first of all, we really want to thank our audience for this 3-day webinar series. Been very interactive with the responses and the questions, so we appreciate that. There have been a few questions during this module, Ron, and you might have talked about some of these. There was a question earlier regarding the safety edge. Question, quote, how do you compact that safety edge?
Good question, and it's not really, I mean, obviously you can see there's a little bit of compaction by that shoe, but that's about all there is. It's not compacted certainly like the surface would be by rollers and so forth. So that's why I indicated initially I had some concerns about what if a truck or car got onto that edge, maybe a few hours after it had been paved, because there really is no compaction other than the little bit that shoe provides. But that has been shown to not really be an issue. But a good question.
Thanks, Ron. Sandra was wondering, has anyone looked at the number of objects along roadways versus the number of items hit? She says, could be easily done now using AI recognition.
Yeah, that's a good comment. Yeah, I'm not sure if folks have looked at that recently or not, but you're right. That would make a good project to use AI. Yeah, I like that idea. Thank you.
Yep, and there have been a variety of questions and comments regarding the clear zone, and it sounds like some agencies have maybe specific questions about clear zone issues. So Ron, the good thing has always been that you've provided your email address. I guess it's okay if people email you after the webinar. Is that all right?
Oh, absolutely. I'm glad to. And if you do, which I encourage, if you have questions, if you might include a photo or, you know, a couple photos to help me kind of visualize the situation, that would be even better, if you wouldn't mind doing that. But no, I'm open to emails always.
Thanks, Ron. We appreciate that. All right. Thanks, everyone.
Yeah, thanks, everyone. And thanks for responding to those last two questions or exercises. Well, that brings us to part 6, which is our final part. I think we're right on time here. We should be able to cover everything. Now we're to the point of what happens if the vehicle does leave the road and strikes something on the roadside. How can we minimize the severity of those crashes? So in this part, we want to describe the basics of countermeasures to minimize the severity of roadway departure crashes. And again, just for review, give you some context of where we've been and where we are now. We spent part of the first 2 days talking about methods to keep vehicles on the roadway. We just talked now for the last hour or so, how can we reduce the likelihood of hitting fixed objects or rolling over if a vehicle does leave the roadway? And now we're going to kind of complete the circle, and how can we reduce the severity of crashes? And a lot of this comes from the AASHTO Roadside Design Guide. Those NCHRP Report 500 series that I talked about, they talk about different emphasis areas of addressing run-off the road collisions, and they talk about one strategy is to reduce the severity of the crash, and that can be done by improving the design of roadside hardware, for example, light poles and signs, and also improve the design and application of barriers and attenuation systems. So we'll look a little bit at each of these. I do want to point out, though, that of course we have less than an hour left. This next part is not going to be a quote guardrail course. We're not going to get into guardrail design or barrier design. We're going to talk about some of the issues and challenges associated with barriers and attenuation systems. I will just repeat this slide. I believe I showed this maybe each of the previous 2 days. This is the kind of the priority scheme or the roadside design strategies that agencies might think about. The first priority, if you can do it, remove that obstacle. If not, redesign it. If not, relocate it. If you can't do any of those, reduce the obstacle severity, make it breakaway. And then the fifth thing would be, if we can't do any of those other things, shield the obstacle, or lastly, delineate the obstacle. Here's an example of an agency that removed the hazard. I don't have a before photo, but there was a steep V-shaped ditch here, deep and steep, was an issue for motorists that left the roadway. This agency put a pipe there, buried it, and you can see they put in some inlets along the way. And so I would say they removed the hazard. Now that roadside is kind of level and traversable, a nice clear zone, and so the hazard was removed. Make it traversable. This roadside generally looks traversable, although it looks like a wetland there, except notice here on the lower left, there's a head wall sticking up, and it looks like, remember the kind of the magic number I called it is 4 inches. This looks like it protrudes, at least here in the foreground, more than 4 inches above the ground. And so that can catch the undercarriage of a vehicle and cause a variety of not good things to happen to the vehicle. And in fact, it looks like that has happened here. You can see some roadside memorials there in the background. Is this traversable? I would argue no. That looks like it's clearly more than 4 inches above the ground, and so could snag a vehicle or cause it to flip over or become airborne or stop suddenly, none of which are good things. Is this traversable? And it may look questionable, but actually this is traversable. Single pipes up to 36 inches that are cut to match the side slope, the tires of the vehicle will actually go over that. Like I said, it may not believe it, but the vehicle, it will be a rough ride, especially the back end will bounce quite a bit, but that is a traversable culvert opening there. If the opening is wider than 36 inches, think about what this agency did. Notice put a pipe there in the middle to make that traversable. Again, it's a rough ride. The back axle really bounces significantly, but it is traversable. Here you see another, this is a larger culvert opening, I believe. We can't really see much of the opening, but notice this agency has installed pipe arrangement here, or a grid, to kind of close off, prevent a vehicle from dropping into that opening. And this is traversable as well. Again, it's a rough ride, but it is traversable. With this design, though, the one issue would be down here. Notice we have to have the opening for the flow, but if a vehicle got so far off the road here that, let's say, its left side was here and the right side was on the pipes here, that vehicle probably would overturn into the ditch there. So that is one concern with this design, but obviously you have to allow for the flow into or out of this culvert. So that's maybe an unavoidable sort of issue there. Where you have parallel culverts, notice slope is cut to match the side slope, and they've used looks like maybe pipes or steel bars across the opening to make it traversable should a vehicle leave the roadway and be traveling essentially parallel to the main roadway. Relocate, I think that's what this agency did, not so obvious. Apparently this was even closer to the roadway originally, and they've moved it back from the roadway. To me, it still looks like an issue. Maybe what they should do is maybe bury that, put a pipe in there and bury that, and then have inlets periodically. Or make it crash worthy. This is a video. This has no narration. It's a silent movie, if you will, but I'll just show it. This is a crash worthy mailbox design. I think it was developed by research or in research funded by the Federal Highway Administration. And of course, one of the issues is, and we'll talk more about mailboxes, but one of the issues is these mailboxes are essentially at the height of the, where the hood would go under it, and these mailboxes would enter the passenger compartment. But this is a crash-worthy design. So let's look at the video here. And actually, I'll run that again. It was pretty quick, but not very exciting, really, if you will, for a crash video. But that's because it's properly designed, and notice the assembly of the mailboxes really kind of comes down harmlessly on the hood of the vehicle. Certainly there'd be some sheet metal damage and so forth, but there should be no serious injury or harm to the occupants. Another strategy for objects to reduce the severity is to provide breakaway hardware on sign supports or luminaire supports. We saw an example earlier for utility poles of providing breakaway hardware. And in fact, the MUTCD section 1D.11 requires that there be crash-worthy sign supports on all public roads. Here you see some options for crash-worthy installations. Notice the one on the left there, kind of the U shape, I guess you call that, bends or yields when struck. We have the slip base, and then we have the breakaway design. This is not a crash-worthy support. This is a steel pipe that is not a crash-worthy support. It will not bend or break away in the desired fashion when struck by a vehicle. And of course, sign support design is or can be a real challenge because the support has to be strong in moment to resist the wind loads. If you think about a large sign is like a large sail, if you will, there's significant wind loads. So you have to have support strong in moment to resist those wind loads. But also, because we want the sign to be breakaway, it has to be weak in shear so that when a vehicle strikes the base, near the base of that support, it needs to break away essentially. And another issue is related to what we've been talking about this morning, is that base or that stub height that's left, again, the maximum is 4 inches, so it doesn't create a snagging issue for motorists. Barrier systems. There's 3 basic categories of barrier systems. There's the flexible, the semi-flexible, and then the rigid barriers. And you can see them, the types here. A cable barrier is considered a flexible barrier, and they will deflect on the order of 5 to 12 or even up to 20 feet when struck. The W-beam guardrail is considered a semi-flexible barrier, and it deforms or moves about 3 to 5 feet when struck. And the concrete barrier is considered the rigid barrier, and it essentially doesn't move when struck. If struck kind of head on, which is not the design intent, but it might crack or be damaged, but basically it doesn't move. And as I keep saying, barriers are fixed object obstacles themselves. They can cause harm when they're struck. And the numbers show that there's about 300 fatalities per year involving guardrail. So to me, we need to be judicious in our use of guardrail and not install unnecessary guardrail. This is a schematic of what AASHTO, the Roadside Design Guide, calls the barrier system. This would be the actual, this is a bridge. This would be the bridge rail. Then you have some length of need on both ends to prevent vehicles from getting down to say the roadway below or to the waterway below. And then you have end treatment on both ends. So that those components, the end treatment, the length of need, and the rail itself make up the guardrail system. And there are courses available that get into the detailed design of that. We're not going to do that in this session due to lack of time. In terms of hardware testing, and by hardware I mean anything that's kind of used along the roadway, whether it's a W-beam guardrail or a cable guardrail or a type 3 barricade used in a work zone or an orange and black warning sign used in a work zone. Those devices need to be tested and approved before they're put out on the roadway to verify that they're crash worthy. And the criteria or the protocols for all of that is based on what's called the MASH manual, the Manual for Assessing Highway Safety Hardware. And again, I'm not going to get into the details of that, but I did want to mention some of the key things in terms of how this hardware in the roadway is tested. There's basically 6 test levels that a device or piece of hardware can be certified for. Notice that here at test level 1, we start out with a small passenger car and pickup truck, and then as we go down to test level 6, notice we're getting into larger vehicles, single unit trucks, box trucks, then tractor trailers, and here's a tanker tractor trailer in test level 6. And you can see the associated vehicle weights, and notice the speeds that are used for testing. 50, 75, 100, 90, and 80. Those are the speeds that are used for testing. And then the angle degree that are used, and really there's only two, 25-degree impact and 15-degree angle of impact. And so notice devices are not designed based on, for example, being struck at 90 degrees by a semi-truck. The angle of impact is relatively flat. And this continues to change over time, maybe not rapidly, but it does continue to be changed over time. And actually, just last week, I was participating in a TRB committee on risk management, and a lot of those committee members are attorneys who represent state and local road agencies. And one of the hot topics of discussion at the committee meeting was, what about designing barriers for the EVs, the electric vehicles, because they're so much heavier than the vehicles shown here. So I suspect that's something you'll be seeing more about in the near future, is consideration of the EVs in designing the roadway hardware. But just as an example, you see here on the left, the white pickup truck, that was maybe the design vehicle in earlier versions. Now we're talking about even larger pickup trucks, or as I said, maybe even moving to EVs because of their weights. But you can see not only are they larger, but notice the bumper height, and the bumper height is critical in terms of striking the guardrail, the barrier itself. And so not only weight is important, but also bumper height is important as well, or center of gravity, I guess we would say. With barriers, considerations include the height, the end treatment, the placement conditions. Is it on a slope? Do we need to do any grading at the end of the barrier? Is there a curb in front of the barrier? And then the length of need, which I mentioned earlier. I think today the 31-inch guardrail systems have been adopted in most states, and that's increased over the years because the height of the bumper on vehicles has changed over the years. Here we see using a barrier to shield both trees on the slope, but also this steep, it looks like a non-recoverable or critical slope. I have a few videos of the MASH testing of various devices. This looks at the MASH testing of W-beam guardrail, two different types. You'll see the vehicles, you can see that pretty well here, maybe the angles of impact, but the one on the left is a standard W-beam. It's 27 5/8 inches high. The one on the right is what's called the Midwest guardrail. It's 31 inches high, and these are both W-beam guardrail. The thing I'd like for you to look at, and the videos are silent, there's no audio with it, so I probably won't say anything once they start. But what I'd like for you to look at, because this is what is looked at in the testing, is, for one thing, does the vehicle remain upright? Does the vehicle snag on any components, like a support post or something like that, which may cause the vehicle to rotate? Is the passenger compartment penetrated or compromised? Of course, that's something we don't want happening. We want the occupants in that passenger compartment to not have to worry about, several inches of crush into the compartment or something like that. So look for those things as you watch these tests. And the other thing I would note is that these are both W-beam guardrail, semi-flexible devices, so they should deform around 3 to 5 feet. So kind of keep that in mind. Do they deflect more than, say, 5 feet or less? I'll run that again since that was pretty quick, but it looks to me like that's maybe 3 to 4 feet of deflection, which would be okay. The vehicle stays upright. I don't see any snagging, and certainly the passenger compartment looks intact or not damaged. So that I would call that a successful test. And those would be the kinds of tests that are done on different pieces of highway or roadway hardware to get the approval to be used on the roadway. Now let's look at the the Midwest guardrail section. To me, that looks about the same, maybe 3 to 4 feet of deformation, which is within the limits. I don't see that the passenger compartment was damaged or compromised, and I didn't really see any evidence of snagging. So I would call that a successful test of that piece of hardware, in this case, the guardrail. I mentioned length of barrier, length of need, and I raised the question, is this barrier long enough? In my opinion, it's not, because it looks like it's still possible that a vehicle could leave the roadway upstream here somewhere and get into that area with the critical slope on it, which to me is the main purpose of this barrier, would be to keep vehicles off of that critical slope. But there's a number of issues with barrier installation and design. One of the challenges is, like you see here, where we have guide rail or guardrail in each direction in the median, and then they come together in sort of a V shape here at the end or at the terminal, and that can create some issues, as this dramatically shows a pretty serious, very serious crash. Notice that arrangement where the rail came together created that V shape, literally launched the vehicle right into the bridge pier. So a very tragic situation there. That would be, in my opinion, certainly a fatal crash. In terms of need, what about this situation? I think I showed this image earlier in the week. I would call this a critical slope. The vehicle would probably overturn, and then at the bottom of that slope is a significant water body that could pose a drowning potential, drowning concern. So to me, this looks like a section of road where barrier would be warranted, but we'd want to look at also at the traffic volume, I think, as well, and the functional class of road. But it seems like guardrail would be warranted there. How about here? Any thoughts here? If you might type in the chat what your thoughts are here. Do you think this barrier is warranted? Obviously, there's one there, but do you think it's warranted, or would it be better to not have? Could we eliminate that section of barrier? Any thoughts? You want to type your thoughts in the chat? Mike can share a sample of those.
Thanks, Ron. First few comments are saying no or not warranted. Another comment, does not appear to be needed. Another not warranted. So that seems to be the trend of the comments.
Yeah, thank you, Mike, and thanks for the comments. And I agree. I don't think it's needed either, because if we look here, it looks like what this barrier section is shielding is this sign, which appears to have timber posts. And I would argue, and maybe many of you were thinking the same thing, I would argue you could make those timber posts break away by drilling holes in them to make them break away, in which case we could eliminate the need for this barrier, which, as I keep talking about, it is and can be a hazard in itself. So I agree with the responses. I think the best thing here would be to make these sign supports break away, which could be done fairly easily, and then just eliminate this section of rail. And I mean, look at the rest of the roadside. To me, it looks like, other than this sign, I mean, it's really wide clear zone. It looks like it's traversable slopes and terrain. So I agree. The best thing there, I think, would be to eliminate the rail. Turn down ends. Hopefully none of you have these. There was a time, maybe 30 or 40 years ago, where these were common, but it was learned that these are really more of a hazard than of a safety issue. And I think I have a video here to demonstrate that.
Various designs of the twisted, turned down Texas twist and anchored.
The narrator is saying this is turned down, or Texas twist is the other name given to it. But you'll see here what it can do, what it does to a vehicle. It literally vaults the vehicle into the air. They roll over maybe multiple times, like you see here. So these types of end treatments should no longer be used. So like I say, if you have any of those, that should be a priority to maybe remove those or retrofit those. There are a number of crash-worthy terminals that are available. We're not going to get into the details of those, but some of the issues are tangent design versus flared, energy absorbing versus non-energy absorbing. But having crash-worthy terminals is important, both from a safety standpoint, but also from a risk management standpoint in helping to defend tort claims. Another issue is grading of the terminal area, which is critical. And this slide tries to show there's really three areas of grading. There's the advance area here, where the vehicle's traveling before impact, and that should be relatively flat to reduce instability. Then you have the adjacent area, as it's called, which is the area around post 1. Again, it reduces instability and provides some soil embedment for the anchor. And then beyond that is the runout area, as it's called, which is a recoverable slope. And in certain terrain, this can be a real challenge. I know in terrain like West Virginia, probably southeastern Ohio, I know we have some situations where our DOT faces some real challenges in trying to get that terminal grading in areas of steep roadside terrain. But that's important for the proper functioning of the terminal. You know, this looks to me, this is Arizona, but this looks to me like the appropriate device is being used there, but I'm not sure about the installation or the grading in advance of or around that end treatment. And here's an end treatment example from, I believe this is Eastern Washington State. As I've been told, the driver of this vehicle was a college student who'd been pulling all-nighters for several days, and so was sleep deprived, you might say. And after his final exams were over, I guess he was heading back to his home, I think in Montana. So he was heading east on the interstate here and apparently dozed off and fell asleep and left the roadway. And you can see there are rumble strips, edgeline rumble strips here, but apparently they didn't wake him up. And so he traveled some considerable distance. As you see here, but he was able to walk away from this crash with just a few scratches, probably pretty shaken up. But I think you can see if there had been a passenger in the front seat, this probably would have been a fatal crash, because you can see how the guardrail actually went all the way through the vehicle, and the vehicle traveled a considerable distance. So terminals are, end treatments or terminals are important, very important from a safety standpoint. In terms of evaluating barriers, we look at the structural adequacy, the occupant risk to the people in the passenger compartment, and then what's the vehicle trajectory after impact. And you saw some of those things in those two crash videos we looked at. I mentioned that there's 3 different barrier classifications. Actually, I think I called the middle one semi-flexible. Maybe semi-rigid is a better term, but 2 to 5 feet deflection, that would be the W-beam guardrail. The rigid would be your concrete, and then the flexible would be the cable type barriers. Over 5 feet, I think some folks talk about 12 feet as the typical deflection for a cable barrier. Some other barrier installation and maintenance issues. The barrier to hazard distance is something that we need to pay attention to. Curbs, we've mentioned terminals, we mentioned mounting height, post support, and also barrier to barrier transitions. The barrier to hazard distance is, as the name implies, it's the distance between the hazard and the barrier. And here we have a rural installation of a barrier that looks like W-beam guardrail, and this is on weak posts. These are weak posts. These will break away when struck. So this is actually considered a flexible device. This will probably deflect 5 to 12 feet when struck. But notice what the barrier to hazard distance is. It looks to me like it's maybe 2 to 3 feet. So this is not the appropriate type of barrier to use when your barrier to hazard distance is on the order of a couple or 3 feet. What will happen if the vehicle strikes the barrier here in the foreground, that will deflect maybe 5, 6, 7, 8, 10 feet and potentially could direct the vehicle right into the tree. So we do need to pay attention to the barrier to hazard distance. And to me, this is not a good installation shown here. Also, soil support is important. It's recommended that there be 2 feet from the back of the post to that hinge point if you're using 6-foot posts. And it mentions that a design with 8-foot long posts placed beyond the slope break past the MASH testing criteria. How about this? I would call this a maintenance issue. Look, severe erosion has pretty much destroyed this shoulder, made it unusable for vehicles. Certainly if somebody's going to use that narrow shoulder for kind of a recovery area, and can't really do that in this case, or if there's pedestrians on the roadway, you can see I think that's not even traversable by pedestrians. But for the purposes of what we're talking about here, a bigger concern is notice how much of the loss of post support there's been due to that severe erosion. So I think what would happen here, if a vehicle struck this rail, due to the lack of support, I think that everything would just sort of bend backwards away from the road, which could actually serve as sort of a ramping effect to cause the vehicle to become airborne and go into the roadside area. So kind of just basic shoulder maintenance and drainage considerations are important, and that might have prevented this situation here. Guardrails and curbs. What do you think here? What would happen here if a vehicle left the roadway, say a vehicle coming toward us, left the roadway, they would strike the curb, and the curb would cause the vehicle to become airborne. And so the vehicle would be airborne when it strikes the rail, which is not the intended impact into the rail, or in certain cases, I've seen where the vehicle will actually go over the rail. So the basic rule of thumb, if you have guardrails and curbs, is that the curb should be flush with or behind the guardrail so that the vehicle will not strike the curb before it strikes the rail because of the adverse consequences that the curb can cause. Need to check hardware periodically, or check for crash damage, for corrosion or rotting if it's wooden posts. Check the bolt torque and cable tension. Check the height. I mentioned barrier-to-barrier transitions. These are important and we need to be sure they're handled properly. Notice in this case, we have the W-beam rail, again, which will deflect about 3 to 5 feet. And then that's transitioned to or joins a bridge rail, which is essentially a rigid object that does not deflect. And you can see here what happens. The steel rail deflects, the bridge rail does not, and the vehicle went right into the edge of the concrete bridge rail. So there needs to be adequate transition, meaning we need to stiffen up the rail so that at the point where it meets the rigid bridge rail, they're both essentially rigid types of barriers. And here you see an example of a way to do that. Notice here's the bridge rail. This is the W-beam rail. And notice as we get closer to the bridge rail, the post spacing gets closer so that the rail gets stiffer. And at the point where they meet here, they should have similar deflection characteristics. But as you saw on the previous slide, if that's not the case, the crashes that occur at those barrier-to-barrier where they meet can be very severe. Here are some examples of some that are identified by AASHTO. This is a W-beam transition to a concrete barrier. And again, notice the additional posts here, the closer post spacing. Excuse me. And actually, this is nested W-beam. So it's actually, I guess, another 2 rails nested together to increase the stiffness. This is what they call TL-3, the tri-beam transition. Notice the closer post spacing as we get close to the concrete barrier. And this section here is what's called the tri-beam. This is a newer design. Notice it's deeper than the standard W-beam. So one of the advantages is it can accommodate a wider variety of vehicles, from a small vehicle, maybe with a low bumper height, to a larger pickup truck that might have a higher bumper height. So that's notice they make use in that transition. It doesn't directly go from W-beam to the concrete. It goes from W-beam to the tri-beam, and then that is connected to the concrete barrier. As opposed to this, notice here we have a W-beam connected to a old style cable on wood post barrier, and that is not only not compliant, but not safe. Be very disastrous consequences, I think, when a vehicle would strike that joint or connection. And just along the same lines, kind of keep an eye out as you're driving your roadways to look for other things, other situations where you may need to replace or update the hardware, such as this installation. Or to identify things like this. I'm not sure what happened here, but to me, this kind of defies common sense. Notice we have the speed limit sign on a heavy wood post, and then a very short section of guardrail here with a sharp, almost like a blade-like terminal on each end. And this, to me, this is a lawsuit waiting to happen, and I'm not sure what people were thinking. Again, had they used a standard type of crash-worthy post for the speed limit sign, there wouldn't even be a need to install the guardrail here. Cable barrier, the flexible type, deflects more than 5 feet, on the order of 5 to 12 feet. And I think we have a video here to illustrate that. Now this is some more MASH testing with the larger pickup truck and I'll run that again, that was pretty quick, and the cable barrier. So again, vehicle should remain upright, no penetration of the passenger compartment. And since this is a cable barrier, the deflection will be on the order of probably 10 to 12 feet. So you might look for that here. So that looks pretty good. Again, that would be, I think, a passing grade for that barrier for this particular test. And then remember the last item in the priority scheme, if we can't do anything else, at least try to delineate the roadside obstacles as this utility has done. And I'm seeing more and more of this as I travel around the country, that utilities are putting this yellow reflective tape around their poles. And delineate the curve when you can. I may have showed this image earlier as well, but notice this is the chevrons, and then they're using the reflective sleeves to kind of highlight or better delineate the chevron. So I would call that delineation as well, of both the curve and the traffic control devices, the chevrons. I think we mentioned barrier delineation as well. You could delineate the guardrail itself as you see here, or delineate concrete barriers as you see here. Notice the lower right here. You may recall yesterday I think I showed this as an example of what was called a profiled pavement marking, and they work well on the pavement. The problem is they are not snowplow friendly because of the profiled nature, so they get damaged easily. And I'm not sure who thought of this idea. Doesn't matter, but I think this is a great idea where you can't use that material on the pavement because of snowplow damage. Attach it, affix it to the barrier itself, and you get the benefit of that retroreflectivity on the barrier, but you don't have to worry generally about snowplow damage. There might be crash damage if a vehicle hits the barrier, but these are very effective in terms of delineating the alignment. And I wanted to say a few words about mailboxes. These are mentioned in the roadside design guide. They are a roadside safety issue because they're close to the road. But as I mentioned here, one of the challenges is that homeowners may view these mailboxes as kind of part of their domain, and so they may customize them to their particular interests or whatever, and that may not be consistent with roadside safety. And this little video, I think, shows, again, it's silent, there's no narration, but I think this shows the crux of the issue. Notice the mailboxes are just above the height of the hood, and they go into the passenger compartment right about head high on the driver, and that would likely be a fatal crash. So that's one of the issues with mailboxes. Another issue is just, the mailbox aside, is just the fixed object nature of some of the support systems, like you see here or here. Notice that's a heavy steel pipe that is not crash worthy. supporting that mailbox. Or you may see arrangements like this for multiple mailboxes. And these can, as I mentioned, become roadside hazards. Here's a video from Federal Highway Administration. In many parts of the country, these brick mailboxes, or monuments as I call them, are very common. This video from FHWA shows I think it's a VW Golf vehicle at street speed at about 25 miles per hour striking this mailbox. And it looks like humans are inside. It's actually a crash dummies. But notice, even at 25 miles per hour, significant impact potential for harm to the occupants, damage to the vehicle. So the AASHTO Roadside Design Guide talks about some general guidelines and principles, and they do have a lightweight mailbox mounted on 4-inch by 4-inch wood posts or 1.5-inch diameter light gauge pipe that's not considered to be a serious safety issue for motorists. And they recommend that agencies adopt regulations for design and placement of mailboxes within the public right-of-way. This can be a liability issue both for the property owner, but also for the road agency. So a review question before I think I have a couple case studies. We might have time for at least one of them. But which of these are common installation issues that could affect the performance of a guardrail? And you can just type the response in the chat. Which of these are common installation issues that could affect the performance of a guardrail? The length, the placement near slopes, inadequate terminal grading, or the color of the rail does not fit the environment? Any thoughts?
Thanks, Ron. And already we have several comments. The most common response appears to be A, B, and C.
Yeah, I would agree with that. That's what A, B, and C would be the correct response. Thank you all for that. And one more. What improvements do you think will reduce the severity of crashes at this location? You see, it looks like maybe a ramp, freeway ramp here. You can see a shoulder, you can see a curb here, you can see a damaged guardrail and a bridge rail here in the background. What improvements do you think will reduce the severity of crashes here? Appreciate any comments you want to put in the chat.
All right, thanks, Ron. The first few comments, getting the curb flush or behind the guardrail, move guardrail out to in front of curb, bridge terminal assembly, proper bridge terminal assembly, move guardrail even with curb, delineators, no curb in front of rail, need proper transition from rigid to semi-rigid barrier.
Yeah, good response. I think that captures it. The rail needs to be flush with or in front of the curb, and we need a good transition here between the semi-flexible or semi-rigid device, the W-beam, and the concrete rail. So thank you all for that. So here we've talked about just the basics of countermeasures to minimize the severity of roadway departure crashes. And I have a couple examples. I think maybe we'll just do the first one. Get your thoughts on this. This is an urban 2-lane road. On the left side here, these are single family homes, fairly closely spaced. You can see a number of driveways. And on the right side is a greenway. You can see a multi-use trail here. And in the background, you might be able to see some reflections off the water. That is a canal, the I&M Canal. It's 9 feet elevation difference from the roadway down to the water level of the canal, and the canal is 6 feet deep. Speed limit on this street is 35 miles per hour. The ADT is 4,500 vehicles per day. You can see, it says there's no shoulder, but you can see there's maybe a foot or foot and a half of kind of stone or grass shoulder. There is one street light right here, and you might be able to see kind of a knee-high chevron right about here. I have a few other photos and also some crash data. In 3 years, there have been 6 run off the road crashes, 1 during the day, 5 at night, and 2 of those 6 involved vehicles that ended up in the canal. And you can also see there's a, I'll call it a short section of W-beam rail right here. So what are your ideas to improve safety on this section of road? And you can type it in the chat, any thoughts you have. Probably a number of different things that could be done here. I'll just flip back and forth with these photos so you can see different perspectives. But what are your thoughts of ideas to improve safety on this section of roadway?
Thanks, Ron. We have comments already, including eliminate the drop-off, edge line corrugations, wider striping, more chevrons. Several comments saying more chevrons, improve the shoulder, extend guide rail length in advance of curve, and additional lighting, rumble stripes on the edge lines, more chevrons at an appropriate height.
Yeah. Yeah.
Slower speed limit. Slower speed limit, wider paved shoulder. Curve warning sign and chevrons, possible advanced curve sign, extend guardrail, etc.
Yeah, good comments, all good comments. And I can tell you what they actually did here. They did extend the guardrail around the whole length of the curve. They did install a curve warning sign with an advisory speed because there was none. They did, behind the guardrail, they installed chevrons, as someone mentioned, for the full length of the curve rather than just one. Also notice here, I didn't really comment on it, but there's a normal cross slope for the outside lane, which means that a normal crown goes around this entire curve, which if you think about it, for traffic in this lane going into the curve, that's really what we talk about, the adverse super elevation, because for a curve to the left, the right side of the road should be higher than the left. But for this direction of travel, a normal crown would mean this is not properly cross sloped. So that's another thing that this agency did, is when they resurfaced the street, they made sure that there was super elevation in both directions of travel. And I wouldn't have expected you all to comment on that because I didn't even mention it. But the other thing they did, which I thought was sort of interesting, I'm not sure exactly why, but they took the street light here and moved it to the opposite side of the street. So it would actually be in someone's front lawn, I guess, which I thought might be a little strange. I didn't know if any of the homeowners might complain about that or not, but that's actually what they did. So they basically did what many of you have commented on. So good work on that. But they also did some additional things in terms of the pavement, cross slope, and then also moved the street light. So thanks for that. I think we're just about out of time. I'm not going to go over the second example here, but we'll just say in the time we have left, does anyone have any questions? And before we do that, before we close, I want to thank all of you for participating the last 3 days. I appreciate your good comments and questions and responses in the chat to the various exercises we've had, and wish everybody a good rest of the day, and hope to see many of you at future LTAP training. So Mike, I'll turn it back to you to see if there's any questions, or I know you have some housekeeping items before we finish today.
All right, thanks, Ron. And there will be additional webinar series with Ron Eck looking to the second half of January. We will be hosting Ron for ADA in temporary traffic control zones, and also a series on tort liability and risk management. So please be on the lookout for our LTAP email announcements for those upcoming webinar series. So at this point, I really want to thank Ron Eck for presenting this week's 3-day webinar series and sharing so much great safety information. Thank you, Ron. And we really appreciate our audience this week as well for your attendance and participation in these sessions. So thanks everyone, and enjoy the rest of your day.
Thanks again.